Everyone, today we are going to see about example 13, that is P is a point in a plane of a triangle ABC and I is the incenter, so that the resultant of forces represented by PA sin A, PB sin B and PC sin C is 4pi cos A by 2 cos B by 2 cos c by 2. So this is we have to prove, that is 4pi cos A by 2 cos B by 2 and cos C by 2. So let me solve the sum. This is the triangle of A, B and C. We point out some point of P and mark a lines. Then AD, we take that AD is a internal bisector of BC. So we frame that is AD is an internal bisecting of BC, and then we point out that incentre from all these sides. So here I is the incentre. We mark I to see some lines. So let me solve the sum. AD is a internal bisector of the triangle angle A, and I is a incentre. So why we draw AD means we have incentre. So while passing through incentre, we have to make one line. So only we bisect that A by AD. Here A is an angle. Angle A is bisected by a line A and D. So this is the meaning of this line. Then we know that these are the ratios of trigonometric formulas, that is BD divided by DC equal to AB divided by AC. So we mark that small c as here having a B and C value. So what value is not having A value? So mark as small a value, and here A, here C. So the value not having is B, so mark as B, and here is A and C, the not valuing value is C. So we frame that C divided by B equal to, taken in a sign, written as sin capital C sin capital B. These are the trigonometric formulas. So we combining this term and this term means we get BD sin B equal to sin C DC. So here we already know that here angle B is bisected by AB and BD. These lines are bisecting these lines. So angle D here AI divided by ID. Here AI divided by ID is bisected by B. Then we written as AB divided by BD, and CI is bisected by AC divided by CD. So these are the angles which are bisecting. Now we frame that these are common, AI and ID are common in this place. So we combine these two, that is AB plus AC divided by BD plus CD, means we get AB plus AC and BD plus DC is BC. So I written as BC. So we written that opposite terms. Here AB opposite term is, with not having term is AB side, which term is having ABC. So C plus B divided by A. This is written in the sign form. So sin capital B for this small b, and capital C sin capital C for small c divided by sin capital A for small a. Then what we do means we are combining this. AI sin A equal to sin B plus sin C ID. We are combining this term and this term. Then now what we have means we already know that what here is a triangle, so it's an lambda mu form. The extended form can be written as here PB sin B plus PC sin C equal to, here lambda equal to sin B and mu equal to sin C. So PB sin B plus PC sin C equal to lambda plus mu is sin B plus sin C. Here what is the internal bisector? PD. So PD. So this is the form we taken from this triangle of lambda mu theorem. Then we already know that sin B BD equal to sin C DC from the above first equation. Then we know we want to prove that the resultant of these is 4 pi cos a by 2 cos b by 2 cos c by 2. We have to add the three forces, that is pa sin a plus pb sin b plus pc sin c. We have to add these three forces. Then what we do means we from this term we know that pb sin b plus pc sin c equal to sin b plus sin c pd. So pb sin b plus pc sin c can be written as sin b plus sin c cd. So now that only I written here. This is nothing but pd. It is not cd, it is a pd. Then what we know means this is in the form of one more lambda mu theorem. This is what lambda. What is the formula of lambda OA plus mu OB? That is lambda plus mu OC. So from we assume that PA sin A is a lambda OA and sin B plus sin C as a mu OB. So we have a formula of lambda OA plus mu OB equal to lambda plus mu OC. So this is a lambda, this is a mu. So lambda is sin A, mu is sin B plus sin C, and OC here is PI. Okay, then we put that PI. Then what we written means we take a second equation and written here. From this we know that sin A plus sin B plus sin C equal to 4. We already know that trigonometric form of sin A plus sin B plus sin C equal to 4 cos A by 2 cos B by 2 cos C by 2. So by equating the fourth and fifth equation, we find out that we substitute this equation in the fourth term. Where is the fourth term? Here having a fourth equation. So instead of sin A plus sin B sin C, we substitute 4 cos A by 2 cos B by 2 cos C by 2. So I substituting here as 4 cos A by 2 cos B by 2 cos C by 2 and PI. So this is the solution for this question. Hope you all understand, and thank you.